Bohr suggested that complementarity might apply to consciousness itself. Mental phenomena might have complementary aspects, like thoughts and feelings, or conscious experience and neural processes, that can't be simultaneously observed or reduced to each other. Just as wave and particle are mutually exclusive but equally necessary descriptions of quantum objects, consciousness might require complementary perspectives that can't be unified into single, complete description. This means the mind-body problem might not have a solution in the traditional sense. Instead of explaining consciousness in purely physical terms, we might need complementary approaches that recognize both mental and physical aspects as equally fundamental but mutually exclusive ways of describing the same underlying reality. As Feynman explored in his work on computation and consciousness, this suggests that understanding awareness might require accepting that complete reduction of mental phenomena to physical processes is impossible in principle, just as complete description of quantum objects is impossible. But it gets even more disturbing when you consider what complementarity means for scientific knowledge itself. If reality has complementary aspects that can't be simultaneously observed, then complete scientific understanding might be impossible. We can have complete knowledge about specific aspects of reality, but never complete knowledge about reality as a whole. This doesn't mean science is limited by technological constraints. It means complete knowledge would require simultaneous access to mutually exclusive perspectives that complementarity makes impossible. Every scientific measurement reveals certain aspects of reality while making others inaccessible. The act of gaining knowledge about one complementary aspect necessarily involves losing access to other aspects. Modern experiments have confirmed Bohr's complementarity principle across every domain of physics. In atomic physics, energy and time exhibit complementary relationships. In quantum field theory, particle number and phase are complementary. In quantum gravity, space and time themselves might be complementary aspects of more fundamental reality. Recent quantum eraser experiments show that complementarity operates even when the choice between wave and particle measurement is made after the quantum object has already been detected. The future measurement choice retroactively determines which complementary aspect becomes real in the past. As Feynman demonstrated in his path-integral formulation of quantum mechanics, complementarity emerges naturally from the mathematical structure of quantum theory. Reality doesn't have contradictory properties. It has complementary properties that become definite through measurement interactions. But here's what's really mind-bending. If consciousness involves quantum processes, then self-awareness might be subject to complementarity restrictions. Complete self-knowledge might be impossible because observing certain aspects of consciousness would make other aspects inaccessible. The act of introspection might necessarily involve complementary trade-offs that prevent total self-understanding. This suggests that the ancient philosophical injunction, "Know thyself," might be impossible in principle. Not because self-knowledge is difficult, but because complete self-awareness would require simultaneous access to complementary aspects of consciousness that can't coexist. Let me bring this all together with something that should completely revolutionize your understanding of knowledge, reality, and existence. Bohr's complementarity principle reveals that reality isn't made of objects with definite properties. It's made of interactions that create definite properties through measurement relationships. The universe doesn't contain waves and particles. It contains quantum systems that manifest wave-like or particle-like properties through specific types of observation. Properties aren't features of objects. They're features of measurement interactions. This means existence itself is relational rather than substantial. Reality consists of networks of complementary relationships rather than collections of independent objects with fixed characteristics. As Feynman understood through his work on quantum field theory and quantum electrodynamics, this relational view of reality extends from microscopic quantum phenomena to macroscopic structures and possibly to consciousness itself. Let's return to where we started. Bohr discovered that reality has two faces. Does that make sense now? You're not living in a universe made of objects with definite properties. You're participating in a network of complementary relationships where definite properties emerge through measurement interactions that make other properties inaccessible. Tomorrow, when you observe anything, remember, you're not discovering pre-existing properties. You're participating in the creation of definite reality through measurement choices that reveal certain aspects while making others forever inaccessible. Complementarity isn't just quantum physics. It's a fundamental feature of how reality, knowledge, and consciousness relate through observation. And that might be the most profound discovery about existence ever made. Bohr discovered that reality has two faces, and I'm about to prove it using the most mind-bending physics principle that makes existence itself paradoxical. You think objects have definite properties. A ball is round. A wave flows through water. A particle bounces off walls. Common sense, right? Things are what they are, with fixed characteristics that don't change based on how you look at them. But quantum mechanics says you're completely wrong, and this discovery is so disturbing that it reveals reality itself operates according to principles that make logical consistency impossible. Let me show you what Niels Bohr understood about this cosmic schizophrenia that even today challenges our deepest assumptions about existence. Start with something simple. You're looking at a coin. It shows heads. The coin has a definite property. Heads is facing up. You can photograph it, measure it, describe it precisely. The coin's state is objective reality. Now imagine something impossible, a coin that simultaneously heads and tails until you look at it, but can only show one face when observed. Not because you don't know which face it shows, because it actually displays both faces at the same time until forced to choose. This should break your brain. Objects can't have contradictory properties simultaneously. Nothing can be two opposite things at once. Bohr realized this impossibility was fundamental to quantum mechanics after studying the most famous experiment in physics, the double-slit experiment with electrons. When electrons are fired one at a time through two parallel slits, they create an interference pattern on the detection screen, stripes of light and dark that prove each electron somehow went through both slits simultaneously, interfering with itself, like a wave. But when detectors are placed at the slits to see which path each electron takes, the interference pattern disappears. Each electron goes through one slit or the other, behaving like a definite particle with a specific trajectory. The electron's behavior completely depends on whether you're watching which path it takes. When unobserved, it acts like a wave going through both slits. When observed, it acts like a particle going through one slit. This seemed impossible. How can the same object be both wave and particle depending on the experimental setup? Bohr's answer revolutionized physics. The electron isn't wave or particle. It was something that manifests as wave or particle depending on how you choose to observe it. Reality itself has complementary aspects that can't be observed simultaneously. As Feynman explored in QED, the strange theory of light and matter, this complementarity principle reveals something profound about the nature of physical properties and measurement. Quantum objects don't have definite characteristics independent of observation. They have complementary properties that become definite only through specific types of measurement. But it gets stranger, much stranger. Bohr extended complementarity beyond wave-particle duality to position and momentum. Heisenberg's uncertainty principle states that you can't simultaneously know both the exact position and exact momentum of any quantum object. But this isn't a limitation of measurement technology. It's a fundamental feature of reality. Position and momentum are complementary properties. The more precisely you determine position, the less precisely you can know momentum, and vice versa. This means quantum objects don't have simultaneous definite position and momentum. They exist in superposition of all possible combinations of position and momentum until measurement forces one complementary aspect to become definite at the expense of the other. Bohr realized that complementarity applies to the measurement process itself. You can design experiments to measure wave properties or particle properties, but never both simultaneously. The experimental setup determines which aspect of reality becomes accessible. Here's the mind-bending result. Reality doesn't exist independently of measurement. Instead, reality emerges from the interaction between quantum systems and measurement devices, with complementary aspects becoming definite through mutually exclusive experimental choices. But here's what will break your brain completely. Complementarity suggests that complete knowledge of quantum systems is impossible in principle, not because our instruments aren't good enough, but because complete information would require simultaneous access to mutually exclusive aspects of reality. As Feynman understood from his development of quantum electrodynamics, this is not a failure of physics, it's a fundamental feature of how information and reality relate at the quantum level. Complete description requires incompatible measurements that can't coexist. This creates what Bohr called the quantum of action, a minimum scale of interaction below which classical concepts like definite properties and objective reality break down completely. But wait, there's something even more mind-bending about complementarity and consciousness.